Okay, hopefully my screen is visible. I'm full screen now, so if there are any questions on chat, it's better to just speak up because I can't see the chat window now. Okay, so just a brief overview of what IBM Research India is focusing on, projects that we are involved in, and which will also give all of you an idea, notion of, is my video on? Okay, hopefully you can see me now. But also give you an idea of how to actually apply the concepts that we have learned to interesting use cases and applications. Okay. So what do we do? As you can see here, the spectrum is broad, but the focus is on cloud and AI. So so if you can see here, we have our a work around trusted data, work around language and reasoning that falls on the AI pillar. And then we also have AI applications, which are mostly about business automation, conversational AI, and supply chain. And then we have projects which lie in the in the cusp of AI and cloud. Right? So it is security, hybrid cloud, and quantum. We also have a group that is focused on sustainability and climate. So broadly, these are the key areas that IBM Research India is focused on and is working on. Okay. Please stop me if there are any questions, as I mentioned before. Okay, let's start with AI for code. Okay? And what do you think it means? Why are we saying AI for code? Any thoughts, any ideas? So what this is basically is two important streams of technology evolution coming together, right? Software engineering and AI. So we have, in all of the talks sessions earlier, we have talked about how humans can understand natural language. Similarly, can we say, can computers understand programming languages? So that is an analogy we can build. When we look at text document, humans can look at text documents, as we have seen, and understand what topics it belongs to, right? Or what words represent a document, for example, or a corpus of documents. Similarly, can computers understand source code? So this is a very interesting cusp of how we are merging or how we are bringing together technologies of software engineering and AI. Now, the focus here is new AI technologies that are understanding IT artifacts, right? So if you look at the thing below here is code repo, logs, test suite, dialog, other application documents, deployment, config, and data model. And so how can AI understand these IT artifacts and do multiple end applications as highlighted here? One is, can we do automatic source-to-source translation? If you have a code in, legacy codes, let's say in COBOL, in Fortran, and now we want to move those codes to Java, can a computer do that? Can our system do that? Can a model do that? Natural language description to code generation. Let's say we have a pseudo algorithm written. Can we automatically generate code from that natural language? And similarly, vice versa, right? Code to natural language description. If we want to kind of insert comments, let's say, or understand give a textual description to a module in a code. Can we do that? When we look at code similarity search, the way we do document similarity, right? So it kind of follows the NLP stack is what I'm trying to bring in here, right? So any NLP application that you can think of, can we bring that in software engineering? And that is the whole idea of AI for code. So you can build a parallel between NLP and software engineering tasks through this. Similarly, code completion, right? When you're typing something in Google, Google kind of auto recommends what can come next. Can we do that similarly when you are actually writing code? Can the system recommend that, okay, this is probably the next function that you should call? Maybe you've done a matrix addition, maybe you have to do a matrix transpose, for example. So can you give such kind of recommendations when you are working on code? So these are different parallels that I'm throwing out, and when you want to bridge the gap between what an NLP stack and NLP applications contain, can you bring that? Okay, so I'll just talk through here what these boxes mean, very high level view. This is basically the data sources that one can have. Again, this is not the exhaustive list. Also, you may not need to have this whole list to go through the pipe. Right? But depending on what your application is, what your use case is, these are some data sources that we can start looking at if you want to kind of start, getting the IT artifacts for software engineering tasks. Okay. So the first block is data management. So you want to do some kind of source repo analysis, right? When we say data analysis at the NLP world, when you look at pre-processing, right? So this is what you can do for source code also, where we say that, okay, let's do some analysis on the code. Let's do pre-processing of the code. Probably we need to mask items that are maybe privacy related. Again, some compliance-based filtering. We need to check if they are compliant and do some filtering around that. And the way we kind of do splitting, in a train test split, we can do all those tasks beforehand. Right? That falls in this big data management block. Then we have the symbolic representation, right? So how can we represent code in a symbolic way? Now, there are various representation methods that software engineering domain inherently comes with, right? So we have CFG, control flow graphs, we have abstract syntax tree, and there can be other graph representative models that we can use to kind of start getting the representation from the code. And this is again, if you want to draw the parallel between what Debanjana was talking about, document representation, right? So that can be a parallel to that NLP task, is code representation, but in a kind of a symbolic way. And then the next bit would be, can we have a more deeper representation and distribute? When I say distributed, it can be the representations can be at a function level, or it can be at the whole application level. So how deep or how granular or how coarse you want to do these representations, that can also be done through some deep net space distributed representation. And there are multiple works that have been started in IBM Research India, where they are doing these representations through graphs by various connectivities, understanding the topology of which who is the caller, who is the callee, etc. So different ways of representations can be And then finally, foundational models, right? So why are we saying foundational models? You must have heard, you know, transformer models, right? That there are millions of parameters that are big models that have already been kind of trained using BERT, using GPT-3, etc. Can we also bring in the same kind of concept here, where codes are lying everywhere, all over the web? Can we do foundational model-based code translation? That is the task that we want to do. And then if you look at other, kind of parallel, when we talk about between NLP and code, the whole idea of, parsing, dependency parsers, POS tagging, etc. Can that be applied to code? So these are some questions that need to be answered. But this is where this domain of AI for code is made in. Any questions? Okay. So I do want to kind of highlight this this important piece that IBM Research India is working on, and this is of microservices recommendations. And what this means is, we have legacy monolithic codes, and when I say, normally the way enterprise applications codes are written, legacy systems is you have a database, you have a client-side applications, you have server-side applications, right? And it's like that's a big, it's like one unit, right? But now with things being more digitized, right? It's a digital age now, and we want to move to cloud, and industries rapidly want to move to cloud, and they want to kind of, leverage the cloud capabilities that cloud computing can give you. So, but that is a big, it's a big problem, right? So now you have this huge, massive code, and you want to start kind of understanding how you can modularize it, right? So when I say modular, can you build microservices that can, that are basically API based, right? So you want to break down this code, and you need to understand how you want to break it so that they are microservices and their components in their own. So, and this is what the whole microservices recommendations is. So this, let's say this is this is kind of, kind of representation of how a monolithic system can look like. It's one big unit. And then you have the code repo, you have other things, other data sources that were mentioned earlier. And what this blue box or the black box would do is extract the microservices from this code and work with the architect, right? So domain knowledge is critical here, because this is a system, right? It still doesn't understand the application. It will understand the text. It will probably understand the meanings. It will probably understand the clusters, but it still needs human feedback to come and tell that, yes, this makes sense. And then what the microservices extraction does after this feedback off and on has happened is it will take, let's say, this is like an airline flight ticket booking thing. It will kind of, as you can see, this kind of clustering these functions into microservices. So flight booking is one service, billing service is another microservice, and each of these blue dots are probably referring to functions within. So now they are now independent components calling each other through API calls, but now they can be hosted. And this goes to the developer. Again, there needs to be a working session with the developer too, to kind of get the feedback of how this will work. And finally, when there is a consensus, then we can go and generate the microservice. And this is a very, very important piece of work in today's world when things are moving to cloud rapidly. The digitization is happening rapidly, and enterprises want to modernize, right? So we call this application modernization, and so they want to modernize their applications. Okay. So, uh, so I just want to highlight two things here. So this is the project coordinate. This is openly available. And this is the, it's a curated data set of, I think there are about 14 million code samples across 400 applications. And this is a good, data set to start thinking on these lines, right? So if you want to work on, say, let's say, code similarity problems or any other problems, it's a good data set to start. So these links will be provided, and there are, you can see there are notebooks, there are different assets here, and there are some potential use cases that have been identified. There is a data set overview, and you can see here that they are in 4 languages, 6 languages: C++, Python, Java, C, Ruby, C Hash. So there are different use cases that you can work using this data set. So please take a look at it, and there are some interesting problems that you want to work related to this, to AI for code. This is the data set that so. And then this is the mono to micro. This is from monolithic to microservices. Again, this is you can get a trial version. There is a demo, but this is understanding how you can create microservices through from a monolithic. This particular link that I'm showing is more on refactoring, as you see here, Java into Liberty microservices. Liberty is a web server application. This is more on that, but we give you an idea of what mono to micro takes. Okay, any questions? Okay. So this was AI for code, and let's get to the next piece. And again, these projects are the cusp of AI and hybrid. So that is where we are. Okay. So next is what's an AIOps. AIOps is AI in operations. Now, what it means is, let's say we have moved everything to microservices. Our application is in cloud. Things are working. We have, different components. That we have a billing microservice. We have a booking microservice, other microservices, and now we have kind of a topology, an application topology built. In enterprises, what normally happens is, we have monitoring systems. So we want to maintain the reliability and the resiliency of our application, right? So we want to kind of make it more stable. You don't want, let's say, Twitter or LinkedIn to go down. And so that is where the whole idea of AI in operations comes. How can you make these applications reliable, and how can you make them more resilient so that they are less prone to failure? So now the persona here, so the persona in AI for cloud were architects and developers. So now they have, and now the persona here is more of operation engineers, right? Site reliability. And their key job is to understand that the systems are running smoothly with less hiccups. Hiccups will happen, but you kind of want to remediate ASAP. There is a time to value factor here, especially for critical businesses where, bunch of money is at stake. So you want to kind of make them more resilient to. So this persona here is more of an operations engineer. He's an operations engineer, and these are the different, I would say, monitoring systems, right? So every microservice will have a monitoring system, which is kind of monitoring that, okay, now there are certain metrics these microservices monitor. They will look at if CPU utilization is going way above, then potentially something is going on. And they will start throwing alerts. So start all these components, each component will start throwing alerts. And you can imagine, right, if a failure has happened and the operations engineer now has to go and debug, and it's a big application with multiple microservices, then you can get tons and tons of data coming from different sources, right? You can have logs coming in, you can have alerts and metrics data coming in, and so it's very difficult to understand and respond quickly. So these terms here, they are mostly, Sysdig is like a monitoring tool, which is kind of monitoring your microservice. PagerDuty throws alerts if something is kind of going wrong. Log DNA is where all the logs are getting processed and aggregated. So these are tools that enterprises use. And then, as you can see here, this is probably how a real, site reliability engineer's office looks like. Right? So multiple dashboards, and he has to kind of now look through all of them and see, okay, what is happening, right? What do I need to do so that this application starts working? My flight booking application starts working. So they're overwhelmed with these dashboards and tools. And if you want to kind of get into one screen here, let's say, this is how logs look like, right? So again, this is just a snapshot of a train ticket microservice here. But as you can see, tons and tons of data, tons and tons of text. There can be structured text and structured, unstructured, but you have huge gamut of data being thrown at you. And it is not, it's more, I would say, tricky because even the data modalities are very different. So the data formats can be of varying different dimensions. Okay, so this is what Watson AIOps tries to do. And this was released in 2020. I think mid-2020 it was released. And we are now at release number 3.4 is the next release that's going to happen. So this is what we finally want to achieve, right? So a fault happens, and now we want to help the SRD understand, first is diagnose, right? Can he actually understand the root cause of the fault and also help him to mitigate the fault as soon as possible? So recommend actions also. And the cool thing about this is there are a lot of these blocks that you're seeing, right? So anomaly detection, even noise reduction, holistic incident story viewer, and automation. Everything is kind of coming in one Slack channel, right? Or a one, I would say, collaborative channel where multiple SREs can come together and work together rather than each looking at the dashboard and maybe standing next to each other and talk. So they can actually come to a unified tool and also drill down if needed, right? So from the tool, you can kind of drill down and understand what is happening, right? So this is a topology. You can understand that, okay, this microservice was calling this and something happened here. It didn't work out, right? So maybe this is at fault, then the Watson AI system can throw in more explainability of what can the root cause be. And then finally, try to automate some of the steps. Like, this pod is probably not functioning. Let's restart it, right? And the SRE says, yes, let's go and restart, and you can automate. And then the other thing is, so if you see here, problem determination, remediation, and avoidance. So I talked about determination. If their fault has already happened, so at a reactive stage, right? So you're reacting to a fault. And you are also kind of remediating, but you want to remediate um, uh, in terms of so that it doesn't happen again. So kind of remediate in a way that probably will prevent the fault from reoccurring again. And then the final key thing is being proactive. Right? So you want to proactively understand that, oh, okay, something is happening. You know, I'm seeing a drift in the way in normal conditions it works. So let's try to do something, right? So let's try to optimize resources. Maybe one CPU is really getting heated up. So let's try to kind of balance the workload and take away some of that somewhere else, for example. And this is what these blocks here mean. So dynamically at runtime, how are these microservices being called? And that is a dynamic quality view. Anomaly detection is detecting outliers, right? So in normal conditions, you know that this is how applications or microservices are running. But since you're monitoring these, you're monitoring the metrics that are coming from each of these microservices, you're monitoring the logs. So you can have log anomaly detection, you can have metric anomaly detection, and kind of proactively determine or forecast that something bad is going to happen. Even noise reduction is mostly, you know, when lot of data coming in, and there might be redundancy, right? So the monitoring tools keep on throwing these alerts to you. And so you want to kind of deduplicate them, right? So you kind of, let's say, cluster them together. So that is the even noise. So alert noise is a very, very key problem in such scenarios. So you want to kind of reduce the noise as much as possible. And holistic incident story viewer is all these things that the insights that AIOPs has provided or has gathered. How can you bring it in a story? And when I say story, it's more like kind of a metadata view of what the system has understood through the data and all the things that are coming in to the SRE. So the SRE, what it gets is a story. Is this is the probable root cause, and this is how you can remediate this. And the final is the infrastructure automation. We want to automate as much as possible. Definitely, we want to be careful of what we automate. So, but automation is also very, very key. So, and the reason why we want to do all this, we want to reduce the mean time to detect, and we want to reduce the mean time to repair. And time to value is key, because you don't want to lose the money because of microservice winter. Any questions? I did see some questions, but it just went off. So if I've answered your questions, we are good. Else, whoever posted a question, can you please speak up?
Yeah, I just wanted to know, say, when you are sharing this data from different things for the SysD, paper duty, and all those things. So, are there no privacy issues that when you deal with this? I mean, to analyze those logs, are they readily available, or if there are privacy issues to be handled?
Yeah, no. So there will be privacy issues, right? So that's why you need to do masking. And so that is, yeah. So the data needs to be masked before it can be shared. There needs to be some contract signed. It cannot be readily available like that. Yes. Any other question? Did I answer your question?
Yes.
Yeah.
Yeah.
Okay. So again, if you want to know more about the cloud pack for Watson AIOps, there is a very numerous blogs and papers around it. But this is kind of the maybe can give you a gist of what it is all about. So again, these links will be shared. Okay, so now let's move to the data quality for AI and why it is needed, and this is also, we heard of all these terms, right? We heard of data preparation. We heard of data pre-processing. And we heard about supervised and unsupervised methods. We heard about labels being given to us. But even if we have ground truth, it is prone to error because of numerous reasons. Like if a human is sitting and annotating your data, he or she might just get tired and annotate it all wrong, or there can be some confusions around how he's. Even humans are confused, right? So humans can also be confused. So that even if with the ground truth that you're working on, that may not be. So that is a very big problem when you want to start your AI model. You're building your AI. And it's a very time-consuming activity, right? The data prep, I think somewhere in some article, I think it was in Forbes or somewhere, it said that 80% of the time spent on data cleaning, data preparation, and data pre-processing. So it's a hard task. Everybody wants clean data, right? Nobody wants noisy labels. But how do you tackle noisy labels? Because that's not the perfect world. And that is the whole idea of data quality for AI. And normally what happens if I think about the way I have looked at it, we get the data, we get a ground truth, and we are building an application, we get the ground truth, and then iteratively we get that this data is wrong once we start getting the predictions. Right? So it's very cumbersome, right? It's more like an iterative process. We take some time to build a model, we're getting predictions, and like, oh, predictions don't look great. Why, right? And then we start looking at what went wrong, and then we saw that okay, this label, this whole ground truth, that doesn't make sense. And these are some real examples, as you can see here. This is the data, the original MS data, as you can see. This is the ground truth, the given ground truth for these handwritten digits. As you can see here, this is labeled as 4. This was probably 4 when I can't make out. This was labeled as 5. Again, this is probably 1, maybe 2. But as you can see, there is the data, the ground truth annotations are not correct. Again, similarly, clothing 1M, right? So if you can see here, and I picked some examples from the ground truth that they had. The ground truth for this was vest, for this was suit, and for this was underwear. And if you go to Amazon reviews, again, there is a lot of discrepancy there. Here they say very good addition to Kindle, cleans and scans, very easy to use, but they give a label of 1 star. Right? And then they say, awesome, it was better than all the other my various school books. I love it, the best book ever, awesome, but they give it a 1 star. Similarly, they will say it is only 6 words, don't waste your money on this, and they give 5 stars. So that is a lot of discrepancy that can be a lot of label notes. And that is just one aspect of data quality. There can be many other aspects of data quality. But just to finish that thought, even if let's say you want to use Google Images, and you want to get some things for ladybug. So, now, if you can see, these are probably your ladybugs, but then this is it's not a ladybug. This is probably an animation to a ladybug. And maybe they're picking these pictures because they're doing a text search. Okay? So here it talks about, let me talk about miraculous ladybug. So these are the data quality issues that can happen. And as you can see here, right? So these are, so even with if you want to kind of do it automatically through like this, then also you can. So Okay, so in our pipeline that Devanjan and Harshit were showing, where can it kind of fits in? I'm sorry, it's probably not. This is a snapshot, but so raw data will come in, and again, the persona here is a data scientist. And see, the understanding persona, especially for your application, is key because you want to know the audience, right? You want to know who is going to consume. And so it's that understanding that persona is very, very key. And that is why I'm highlighting these terms here. But it kind of sits here, right? So you've got the raw data here, you detect the data quality, and you kind of review, you give some recommendations. You say that, okay, these rows are not good, or this label seems wrong, or this data is not homogeneous enough, right? You say, let's say, we talk about, one column is about countries, but suddenly some other non-country names come in some reason. And so you understand that and say, okay, this column is not homogeneous. And you review your recommendations with the subject matter expert, and once the review is kind of done, then that is the data that we use for the parts that we have already seen. So let me show you this the IBM API Hub, and I will show you the data quality API here. But there are 2 APIs listed here that you can try out. There are some trial versions that you can see. So this is the data quality for API. So if you get a trial subscription, this has a 6 months trial subscription. Okay, and so you can put this in, and you will get an email that it is valid till this date. Sorry, and yeah. So, but since I already have this, so let's try this API. Okay, so yeah. So when you do the trial subscription, you will get an email, and then you will get your security keys. Okay, so I have mine. So what we can do is we can take this, we can check the connection, and hopefully it will work today. So this is the connection check. So you can try this API, give your client ID. Okay. Okay, so it's a success. So it says microservices alive even. So let's go ahead. So here they have for structured data, but there are also data quality checks that you can do for other kinds of data, right? For, let's say, for spatial time, temporal, time series data. So there are other things that you can check the quality of the data for. This is the label noise that I was talking about, label purity, but there is also data homogeneity, data duplicates, data completeness that you can, other data quality dimensions that we can have. So, but it's very kind of this API is very easy to use. So if you go to label purity, and I've just taken this from this is a breast cancer data set. Okay. And then you can give a label column. And if the label column is not given, it will take the last column as default as the label. So now it says this is submitted. You take a job ID, which is this. Go to get results. I hope it is done. Submit the job ID here. Now what this will give you is basically give you kind of what it has kind of understood in terms of what samples are noisy. There are some details it gives you in terms of we are checking for label noise. And this it took about 13 seconds. These are the results. The confusing noisy samples were for this. And the reason was they were lying in some overlapping confusing regions. These are the rows. The actual label was 0. Maybe it is 1. So this is how you can use this API. So please feel free to do the trial subscription and for 6 months you can play around with these data quality dimensions. Any questions? Okay. So moving on, let's do trusted AI. Again, trusted AI has a lot of dimensions, but what do we mean by trusted AI? And one of the very key things about trusted AI is fairness and bias. Before going here, let's look at what Google images are. Favorite Google images are telling us. Let's give. Let's talk about occupations. I think that's easy. I did nanny. You can see, right? Okay. Do you know what I'm talking about? Can you see what is happening here? Can anybody tell me what is happening? Yes, please speak up. Are folks still around?
Taking care of child.
Okay.
It's searching for the term nanny associated with images and giving up those images.
Mm-hmm. Yeah, all good. All good things. Yeah. Anything else?
I think it is showing some bias in gender, like it is showing female.
Mm-hmm. Yes. Good. Yes. So yeah. So as all of you rightly said, nanny. Yes, it is talking of it's taking care of the kids. It is probably getting the like we did for Ladybug. It's probably getting the words from here. But more importantly, there is a bias, right, towards gender. And maybe many of us didn't even realize that this is happening. And it's an unconscious bias. So all are women. Any other occupation you want me to try?
All the caretakers are women.
Yes. Correct. Could I try any other occupation? Let's try one more. Let's try carpenter. Can you see here? There is one woman here. I think she's a woman here, but they're all men. So models can have bias, right? And so you need to be fair. And another example because Harshit was talking about financial domain, loan, right? Home loan. If you're always seeing that home loans are not being given to certain age brackets, then that's a bias. So these are some, there are some conscious bias, there are some unconscious bias, but the AI model should be fair. And that is what we talk about, fairness and in fact, there was a very good article long time back, I think it was 2016, Debanjana talked about word embeddings, where it said debiasing word embeddings, right? And it would say a man is to king as a woman is to queen, and then it will say a man is to woman as a doctor is to, and it will come as homemaker, right? So as you can see, these models will, and that is what the data is giving them. So, and where does that bias in the data comes from? Let's look at that also. Let's look at this figure. I hope it is big enough. So, what this data set did was it basically threw these pictures of random pictures to participants and said that, can you just give me some words that describe these pictures? And if you see here, ceremony, wedding, bride, man, groom, woman, dress, it's perfectly describing a wedding, right? Similarly here, bride, ceremony, wedding, dress, woman. These were the most common words that came out for this picture. Similarly for this picture, ceremony, bride, wedding. But this was person and people. Any idea why this happened?
Dressing.
Correct? Dressing, yes. Anything else? So I'll tell you why this bias happened, right? Maybe the population sample that they picked up were all from the Western regions, right? So the geography also is matters here, right? So maybe even I don't know that this is a wedding attire for this is a wedding depiction that this image is giving. So that is why this, and it's nothing wrong with the folks who are giving these words to them, but it's just that they don't know, right? So that is how kind of, this bias kind of, or this is an unconscious bias. You kind of don't know what it is. You don't know the attire, right? You don't know that this is a wedding attire, right? So, and that's why you just say, okay, let's be very vague and say person and people. So this is how it kind of creeps it. This is again a work that was done in IBM Research India. This is on our beloved Bollywood domain. But what they did was they took movie posters, they took movie descriptions from IMDb and other sources, and they kind of did some analysis on what is happening in our movie world, right? And if you see here, just see, the adjectives with males. Poor, rich, strong, wealthy, honest, real. And with females, it's beautiful, it's attractive. I'm not sure why dead is there, but okay, lovely, married, right? Poor. So these are like, so these are the examples that you are seeing coming from this data set. This is too low, but occupations used with males. So it was mostly, student, lawyer, gangster, police officer, etc. Occupations that were used with females were secretary, student, police officer. But the percentages are very low. You can see them well. Some of them are getting depicted as police officers, but that percentage is very low. So this is the whole, how can we make our models fair and unbiased? So that is the whole idea of trusted AI. Okay? This is one aspect of fairness and bias. The next aspect is explainability. when we look at, the algorithms that we have seen so far, be it unsupervised, supervised, that, I'm sorry, I'm not sure why they're all picking up together, but let them keep up. But when you're predicting something or when you're defining clusters, you want to kind of explain what is happening, right? Or like the medical example, right? This is a perfect example of explainability. If you're giving a recommendation to a doctor saying that this is what you should, this is probably this is what is happening to the patient, and you kind of give a recommendation, you need to give good amount of explanation to the doctor there for him to kind of trust you, right? And say, okay, I understand you, I trust you, and let's go forward with it. And especially for critical systems like health, or maybe an air traffic controller system, where lives can be at stake, explainability is very, very important. And I will tell you another explainability angle that we do in AIOps if you go to some slightly less critical systems, is when you're doing a code change, right? And I'm talking about faults and everything, but somebody's actually trying to push a code, doing a code change. If you're telling that this code is, you're being proactive, right? And you're saying that, oh, okay, this code will probably make something not work, right? But the developer should understand why will it not make something work? Am I such a bad programmer or what, right? So I think this explainability is very, very key, be it critical or be it non-critical. But it's a very, very key aspect of how one can trust an AI. And the final is, not the final, but it's about adversarial robustness. So I think somewhere in Harshit's talk today, we talked about adversarial networks and adversarial perturbations, right? Now, if you look at this top image, it's Nadal, and it was given, this is, I got this out from the ImageNet database. You put it to a classifier, it kind of tells, these are the top 3 inferred captions. Right? So a man is holding this, a man is holding a pen strap, but a man is holding a strap. But it's slightly, currently the adversarial perturbations are so strong that even with slight perturbations, a human eye cannot understand the difference, right? So this is a perturbed image. A human eye cannot understand the difference. But if you can see here, the same model has now totally gone crazy with the captions. So it's a woman brushing her teeth. So how can you make the AI models more robust, less tuned to attacks, right? And so these are the key, few of the key dimensions to trusted AI. This is actually, this is a real, let me play this. So this is a original turtle, printed turtle. So classified as turtle, as you can see here. This is kind of the classification it's kind of doing. Now they've perturbed it. Looks like a turtle to us, but as you can see, it classified it as right. So adversarial attacks is important to know that it can happen. Yeah, so these are, so okay. So to end this note, so we have, I've also mentioned some, I know somebody had mentioned privacy. Privacy is key, robustness is key, explainability is key. Uncertainty of the model, we talk about confidence intervals, that is key. How certain is the model in doing your predictions? Like if, a weather data is saying, okay, 40% chance it will rain tomorrow, you might still carry on, right? Because you don't trust, maybe. And finally, testing, right? We talked about validation and all the concepts here, but these are key factors for adapters of your AI models to trust your AI model. Again, this is again, you can use it. This is the AI Trusted AI Toolkit. This is the AI fairness toolkit, but there are others that you can get here: AI explainability, AI privacy, robustness, quantification, factory. I'll quickly run a demo since it's already here. But you can get Python docs, right? So you can get notebooks. So the notebooks are pretty exhaustive. So you can definitely run these notebooks. Okay. So let's go to the demo here. So if you click demo here, there are 3 data sets: Compass, German credit scoring, and adult census income. And the protected attributes, as you can see here, are race and gender. So what this is doing now is basically checking if there is any bias in the data set. And so now you can see there is the statistical parity difference should be closer to 0. It is not, so there is some bias. And next is how can you mitigate the bias, right? So there are different bias mitigation algorithms. Let's just try one. Just one. And all the details of these algorithms are there in this site. So you can see it's everything fair now. In fact, for some dimensions it has improved the fairness, but it does drop the accuracy a bit, right? Maybe not significant enough, but it does drop. And you can play around with different bias mitigation algorithms. So here the accuracy drop was less, but it kind of changed much. So and if you look at the notebooks, as I said, very explanatory. You can work through them. These are some examples that you can use. And please use this website if you're interested. Okay, I have 10 more minutes, so I just want to wrap it up fast. Conversational AI, I think, very critical also. There can be different types of conversations, right? One is chit chat. So you're just having a chit chat with a friend or with your colleague. And one can be task oriented or task specific conversations, right? So if it is task specific, the designer wants to know what are my intents, right? What are the goals and objectives that can come, and maybe some intent examples, and how should the system respond, and what is the dialogue? So these are some common questions that a designer wants to know before it can start building a conversational AI. So what are the users going to ask? If you have some idea about them, how are they going to ask them? How will the conversation proceed? So IBM Research has IBM Watson Assistant, which is a conversational AI tool. And as you can see here, this is kind of to give it a data set. This will help you find the intents by grouping most common, by clustering the most common examples that the data set has, right? So these are some examples of that. But beyond that, if you have now a bot designed which looks like this, and the agent it is typing how may I help you, and the user is said I need to reset my password. You also want to assist the agent in kind of helping him or her to help solve the problem, right? So agent assistance is basically what the agent can look at, right? So it will start giving you recommendations. So this is something that you can do, and you can check out this page. You can check out this page. It's more like a recommendation system, but it's also critical especially in an enterprise setting where this is very key in terms in the technical support domain. Okay. Lastly, the Watson NLP library. So we have this effort started in 2019, but what is Rule? It is what it does is it kind of collates and every different NLP libraries that you can think of, starting from basic to advanced, out of the box to supervised, unsupervised methods these libraries can contain. So some examples where you can see, it has language identification library, sentence detection, can detect the boundary if it is a sentence or not. What Devanjana was talking about, tokenization and lemmatization part of speech, dependency parsing, shallow semantic parsing, mostly semantic roles given to these phrases, and then rule-based techniques, right? So classification, table header identification, for example, MLAI techniques, classification, clustering, entity extractions, language models, code reference resolution, and some out-of-the-box models that are already trained, that can detect generic entities and generic DBpedia concepts, right? And generic relations from your data. And yeah. Okay. So this again, this is IBM Cloud. So this is the power of having the power of cloud, right? So you can go to cloud and go to this. So when you click there, you can go to the catalog. And as you can see, these are, lot of different things that you can actually get a trial or a light version of to begin with. And in all of these categories, not only NLP, but you can get Watson Assistant here. You can search for this to get Watson Assistant. If you want to use the Jupyter Notebook capability, when you go to Watson Studio, yeah. So as you can see here, these are the different plans, right? There is a free pricing, but there is a limit to it. So please be aware of it. And there is a paid plan also. You can select a plan. I'll not go through these steps here, but it's very straightforward, right? You click here and you just create, and you can go with it. Let me see if I have one open. Yeah, here. So this is, so you can create a project, right? And in a project, so if you want to add a new asset to a project, so you can add a Jupyter Notebook editor. So, and you cannot, if you use SPSS, there are other things you can do, but I think for our tutorial purpose, this is what we are invested in. And then, the code that you have been working on, you can just run it on cloud. That is one key thing. The other key thing is, so the idea of what's an image, right? So once you, actually, let me show that. Let me create one. Yeah. So you need to give a name here, okay? And then here you have different runtime options. Which here, as you can see, it's a default Python 3.8 plus Watson NLP. Yeah. So you can use this and hit the create button. Give some name here, and the notebook gets created for you. So once you have that, you can now use this notebook and use Watson to import Watson NLP, and then you can start calling these Watson NLP functions, like for example here. So this is basically extracting nouns and noun phrases for this data set, which is a car complaint. So as you can see here, it basically for every model, what are the nouns that it kind of it's seen, and what are the noun phrases it's indexing. And you can do a lot of analysis using this, the Watson NLP stack. Okay. Any questions? Please email us if you are having difficulties using the toolkits. Okay. So just to end on that note, there are some events planned, and I just want to highlight here. There is a social hackathon that is being planned through IEEE WIE, and this is going to be very it's going to be an exciting hackathon. You can see the timelines. It's kind of it's following a pyramid model, but but this is the timeline that is now. So there is, it's a long term, I would say, process which will give time for folks to understand the concepts and apply it to a socially relevant problem. The focus areas for this hackathon are smart farming, education, sustainable development, and healthcare. These are some examples that are examples of proposal titles that have been given. Parvati, anything you want to add to this?
No, I think when I look at the cross-section of all the participants in this course, Pratiti, I think we have professional students and also academicians. So be very happy to see all of you participating in this hackathon and contributing for social cause. So that's why we called it a social hackathon. So all that you have learned, and there is also a possibility that we would offer a follow-on to this tutorial based on your feedback and response. But the culmination of all of this is when you can put some of your ideas into action. So that's really the reason we thought this hackathon would be a nice idea. So I greatly appreciate your participation here. Pratiti, I want to take a moment to thank Harshit and Harshit, thank you very much for the very detailed description into how the classification can happen, how we come up with the whole theory. And I think the interaction with the team was excellent. Thank you very much. And thanks, Pratiti, also.
Yeah.
For,
Thank you. Just one last note. I think a form will be sent out.
I have sent the feedback form.
Okay.
I was just getting to that. Yeah. I wanted to say before you leave the meeting, just take a minute or more to leave your feedback. That's exactly where I was getting to. I think the team has put in a fantastic amount of effort to compile and present. So your feedback is the gift, I would say, that would help us further frame such courses going forward. And therefore, please take that minute to fill the feedback form. And I think it should not take more than a few minutes. I did it myself. And so, yeah. That's all, Prithvi. Yeah.
Okay.
Thank you.
Thanks.
Excuse me.
Yes.
I'm sorry to interrupt. I
Yeah.
have a question, Pratiti.
Yes.
So I'm Rajeshwari. I know you would. I really loved your talk about this Watson NLP. This may be very naive question, but forgive me if it is. So my idea is these NLPs are these AIs are trained only for the languages, the human languages, are if we can train that for the so I'm from biology background, so if I want to understand the coding inside the cell in terms of the protein sequences, the DNA sequences, so how easy can I actually use these tools for train them to identify certain sets of like some extraction can I get from that, some identification that, okay, this particular sequence belongs to this category, this function. So such kind of work.
Yeah, I'll give you my viewpoint. Harshit, Debanjana, Suranjana, if you're on, you can chime in. See, at the end of the day, what we're doing are representations, right? And
Yeah.
we're representing language in terms of vectors, right?
Yeah.
And then the whole processing is done after that. So
Yes.
in terms of in your domain, yes, it doesn't start with documents. And the reason why it's called NLP is natural language, right? So we're talking
Yes.
about languages across languages.
Yeah.
But finally, what we are going after is how we are representing them in a concise way that one is concise enough, but also what how a system can understand it. So yes, we can definitely transfer these to these knowledge and concepts to the domains that we're talking. In fact, when I was talking about AIOPs, right, they're all
Yeah.
metrics,
Yeah.
right? So they're all metric values. So they will have, like CPU utilization is some value, response time is, and tons of metrics that are provided. A huge, we call it telemetric data, right? So
Okay.
yes, it's definitely possible.
So
Not exactly the way it is, but the concepts are definitely applicable.
yeah, so in case if I can represent my data into some matrix, so you mean it can be done. So in the
Yes.
matrix representation, it will be a different based on my domain. But
Yes.
once that matrix is represented, then the tools can be used. Is it right?
Yes, yeah,
Rajeshwari, I would also like to chip in here, right?
yes,
You do not necessarily convert your data into metrics.
Okay.
What we are trying to convey is that traditionally, AIOps models have been developed for images. This is where it starts from. All the AI models, they
Okay.
are for images. Then the language people, the linguistics, natural language, they developed AI models. And your question, I really like your question, Rajeshwari. Can I do it for genome sequencing, biology, protein sequences,
Yeah,
right?
similarly to
Nobody,
the human language.
nobody has done that, right? People have done it only for images and only for text.
Yeah,
Think
they used the
somebody,
different methods, but in this kind of models, it is not there as far
yes,
as my knowledge is.
yes, somebody should take the protein sequencing data, genome sequencing data, and all that, biology data,
Yeah.
and and train a model. It
Yeah.
doesn't has to be metric. It doesn't has to be. You just need to throw in all the data to
Yes.
some AIOps base models such as BERT, such as there are lots of these models, and there are some models for I know have recently come up for the medical domain. There have some models that have come for the law domain, but not the way you are thinking. And I think somebody should do that. Yes,
Okay.
and it's
Thanks.
doable, very much
Yeah.
doable. Yes.
Yeah. Thanks a lot for this wonderful session. For all the speakers, I would really appreciate this conference. I learned a lot. Thanks a lot.
thank you.
Thanks.
Any other questions?
Maybe Pratiti, before we leave, just like yesterday, if we can just take a quick pick.
Okay.
Nice. Yeah, and at a minute again, if we're done with the feedback, I just realized I put it in the all chat now. So yeah,
Can you
and
please turn on your videos?
yeah,
Is that what you were asking for?
yes, exactly. I was asking for a video. Yeah, that's right. And Rajeshwari still has question. Okay.
No, I don't have question. No.
No, I your hand went just down. So
Yeah.
it's joking.
Rajeshwari, please drop your questions through email, right? I mean,
Yeah, sure.
Yeah. Ranjana, Suranjana, I think we have more presenters. I mean, it's non-trivial that on a weekend takes 6 hours to come and present to the team in a true spirit of wanting to teach and wanting to learn. I think greatly commendable. Yes. Thank you, everyone.
Parvati, are you taking a screenshot?
Yes.
Okay. I think more folks are looking on the camera.
Hey, okay. There are two screens of people. How do you take a pic with all of them? Maybe I'll have to shift the screen and do it one more time. Yeah.
Okay. It's others if Bhumika, Dayanand, Lakshya. I'm just reading out names. Manish, Rani. It's nice to see all your happy and tired faces.
Is Suranjana around?
I think she dropped. Yeah, she was around for some time.
Just one more second here. I need to just make sure. Okay. All set. Thanks, everyone. Time.
Thank you. Thank you, and email us with more questions. Thank you.
Yes. I will also send the feedback form in mail. So I hope all of them are registered, right? So we can
Yes.
follow up in mail as well. Yeah. Thank you.
Thank you.
Also the slides, please share the slides with us if possible.
Yes, will do.
Yeah, thank you.